Alright, I want to talk about section 1.8. We're going to continue on from working with exponents from last time, but this time we're going to throw in those variables because, that's kind of what we do in 7th grade. We learn it with numbers, and then now we start talking about it with variables. So, for example, last time we looked at the example of 4 times 4 times 4, or some kind of amount of 4s being multiplied, and know that we can rewrite this more simply as 4 to the third power. Well, in fact, we can do the exact same thing with variables. So I can write x times x times x times x, and I can simplify that instead as x to the 4th power, or x times itself 4 times. And this makes it much easier for me to write things like this. Just like before, this is our exponent, and this is our base. And that is key for when we're going to be talking about what happens next. Now, occasionally, we need to move things from their exponent form to their expanded form and back. So in this case, if I had y to the 3rd power, and I needed to write it in expanded form, I would simply write it as y times y times y. But in fact, we're going to need to do some more simplifying than we were doing before. So take a look at this example here. We have m to the 3rd power times m to the 2nd power. Okay, so what do we do when we have variables multiplied by themselves when there's exponents going on? Well, what I can do, I can simplify both of these into their expanded form, and this will allow us to create a rule that we can solve these for later. So I can write m to the 3rd power as m times m times m, because I know those to be similar because we just did the expanded form. And I can then write m to the 2nd power as m times m. And they were multiplied together before, so I can multiply them together again. So now I can see that I have m times m times m times m times m. Well, that's easy for me to do because I know when I'm writing shorthand or when I'm going back and forth from expanded forms, I know that this is m to the 5th power. So if I return back to where I was before, I can see that m to the 3rd power times m to the 2nd power is equal to m to the 5th power. And in fact, this will be true wherever I find this to be the case. And I can come up with a rule for whenever I'm multiplying. Let me move some stuff. I got some stuff in the way. Whenever I'm multiplying powers together, all I do is I add the exponents. And this is what this rule looks like. Let me find, here we go. Looks like this. If I have x to the a times x to the b, I have x to the a plus b. And that simply tells me that if I have a similar base, notice my bases are the same, and I have exponents that are different, all I do is I add those exponents together to simplify what I'm doing. Let's take a look at another example. Say I have y to the 5th power times y to the 4th power. If I were to simplify this, all I need to do is I need to remember this rule. And this is our golden rule number 1 of exponents. I can apply this rule, and I can just say, well, this is equal to y to the 5 plus 4, or y to the 9th. Very, very simple for me to do. Now, I have another thing that I can see, though. This is going to lead us to creating our rule number 2 of exponents. And the key to this assignment is going to be choosing which of these 2 rules we need to use, and how do we then solve the things that we're given. For example, take a look at this one. X squared to the 3rd power. How do we simplify this? Well, this doesn't fit with our rule before because we're not multiplying two things by their power, so it isn't going to work as well. However, I can use what I know about exponents to craft this in a way that will make a little bit more sense. So again, if I break this into its parts like I did before, if I turn this into expanded form, this time, oddly, this whole thing right here is the base, and this whole thing is the exponent. Seems a little weird that an exponent can be inside of a base, but it does work out to be this way because we have the parentheses, and the parentheses don't care what's inside of them. All the inside is just multiplied by that outside exponent. So that means that I have x squared times itself 3 times. So I can write this as x squared times x squared times x squared, because I'm multiplying x squared 3 times by itself. Now, if I break apart each of these again into its parts, I can see that I would have x times x times x times, times x, 1, 2, 3, 4, 5, 6. I have 6 x's, multiply them by themselves. And in this case, I know, using my expanded form back to exponent form, this is going to be x to the 6th power. That means my original one, I'll rewrite it because I made it kind of messy, x squared to the 3rd power is equal to x to the 6th. Notice, if I add these together, that is not 6. That is incorrect. So this will lead us to our second rule of exponents. Because notice if I add them together, it isn't correct. But if I multiply them together, it is. And that is our rule number 2. Let me find it real quick. When we have our rule 2, looks like this. I want to make sure I read it right. Yeah. X to the A to the B is equal to x to the A times B. Notice that it is very similar to our previous rule, but the key is this parentheses and knowing when to apply it. So in our previous rule, when we multiply these bases together, when there's no parentheses, all we do is we add them together. And we kind of saw why when we break them apart. However, in this rule number 2 here, when we bring a whole group to another exponent, know that we multiply those bases together instead. We'll do a couple of examples if you feel like you don't get it. If you do, go ahead and go on if you'd like to start trying to simplify. Let me make sure I'm not missing anything else. Okay, example 1. Let's take a look at x to the 6th times x squared. Well, I know that I do have parentheses here, so which rule am I going to be using? Well, I am just simply multiplying these together. So that means I'm going to be using rule 1 here, rule 1. So I know that I just need to add them. So in this case, I can write this as x to the 6th plus 2, or x to the 8th power. Easy enough. Let's take a look at another example. Example 2. In this case, x to the 4th squared. Well, which rule am I going to use? I can see that I'm raising a whole set of variables and their exponents to a power. So it looks like this. I'm raising it to a power, so I'm going to multiply those bases together. So I have x to the 4 times 2, which is x to the 8th power. Okay, a couple more. Example 3. Y to the 5th times y to the 12th. Well, for this I'm going to use rule 1, because I'm just simply multiplying these bases together. So I have y to the 5th plus 12, which is y to the 17th. That's quite a power. And lastly, we'll go example 4. Let's take a look at y to the 5th to the 10th. In this case, I am going to be using rule 2 because I'm bringing a group to a power again. You can kind of see how that looks. So I'm going to multiply them. So I have y to the 5 times 10, and that is equal to y. 5 times 10 is 50, so y to the 50th power. Good thing I don't have to write all that out, because that would take the rest of the page if I was doing y times y times y for forever. So as you can see, it's a handy way to save some space, and it's kind of an interesting concept. Go ahead and good luck.